Okay, we're going to work through the review for our Chapter 6 test and make sure that we can do all of these problems. I know it may be hard to read some of these, but remember that you all do have a review sheet that you can refer to as you work, and that's kind of what I would recommend that you do so that you'll know what's going on, is that you work through these problems with me. Looking at number 1, we have a polynomial here of degree 3. That's the highest power that we have, so remember that we know that. And we know that being of degree 3 means it has 2 turning points. Now the reason that we are interested in the turning points is because in the directions it says, please approximate the coordinates of each turning point by graphing this thing in a standard viewing rectangle. So we know what we're going to expect on our calculator's picture. But actually the problem is quite simple because really we just use the picture in our calculator to get that. So the first thing that we do is we hit y equals, we type in the function that we have, and then we graph this. So after you've put in the function, you hit graph. Now, as far as graphing, if you don't already have it in a standard window, you may actually want to hit the window button, remember, the zoom button, to change your window to standard, since the problem says to use a standard viewing screen. That's number 6. And we can see, like we expected, that yes, there's 2 turning points. Now to approximate these, actually we just look and say, hey look, that looks like a minimum, and this over here would be a maximum. So let's use our technology to get those values. I'm going to hit second, and the trace button above that is calc, so second calc. And then I'm going to ask minimum. So enter on number 3, the minimum. The calculator actually communicates quite well with you on this. First it says, tell me left bound. So you take your cursor and literally scroll to the left of the point that you're interested in. So once I'm to the left, I can say enter. Right bound, I'm going to scroll to the right of that point I'm interested in, of that minimum. And then at the end, I'll say enter so that it can isolate it and figure out what it is approximately. Here we have the first point that I've written over here on the right, which is about negative 1.00 and y equals negative 6.5. So that's our minimum value. Now for our second turning point, what we will do is the same process, except now we'll say maximum. So second calc, maximum. Again, the calculator says left bound. So I'm going to scroll over, but again I'm going to stop on the left-hand side of the point I'm interested in. Then it says right bound. So I'm going to go to the right and hit enter. Then enter again. Here I get x equals 2, y equals 7. So I put here 2.007. And again, you don't need to put the zeros. That can be assumed. The directions did say to the nearest hundredth, so as you're working other problems, you would have rounded to 2 decimal places in the case that you had numbers that you needed to round. Here we're fine. Okay, let's move on to number 2. It's also kind of a calculator problem. We have this function s of x. And it's telling us to really evaluate it where x is in between 4 and 20. So let's read the problem and see why it's doing that. It says that s of x is an approximation to the number of salmon swimming upstream to spawn. So s would be the salmon that are swimming upstream. Okay, number of salmon specifically going to spawn. Okay, where x represents the water temperature. So x is the water temperature. Remember, I've told you guys, the most important thing in these problems is identifying your variables. It makes things a lot easier when you're trying to make interpretations. So the question then says, okay, so we know the x, we know the s. That's temperature in degrees Celsius, by the way. That's important. Find the temperature that produces the maximum number of salmon. Now, the importance here of giving you these x values is, remember we've talked about maximums and minimums in class, knowing that local ones happen on the bumps, but as far as the global extremums, the global maxes or mins, it's possible that on this picture it could happen at one of these endpoints. Maybe it would be going up forever, or something over here on this end forever. So we do want to look at this viewing screen of 4 to 20, since that's what it's telling us is valid. So let me key in this function. I'm going to again hit y equals. I'm going to clear out my other one. Let's see, we have negative x cubed plus 6x. So I'm going to go into my window first, and for x min I'm going to put 4 because it told me that's the lowest value that x can be equal to. And then for the maximum I'm going to put in a 20. Now the function that we have that best uses us just telling the x values in our zoom is the zoom fit. So I hit zoom now after the window. And I'm going to go into zoom fit, which is 0, and ask it to please use those x's to find me the best picture that it can. And here we see something like this. So this one right here is actually a very easy example because even with the viewing screen, it's really easy to see what the maximum is, where the maximum is. So to find that value, I'm going to say second calc. Remember, our goal was to find the maximum temperature. So I'm going to say maximum left bound. Where's my cursor? I can't see it. I have to come up. Oh, there it is. Okay. I'm going to hit enter. Then I'm going to go to the right. Remember that for finding this stuff, as long as it's on your viewing screen, you're good to go. The calculator, however, will give you an error if it's not on the screen at all. And then I hit enter for guess. So here I have a maximum, x equals 12.00 going on, and then y equals, looks like 6,592. So again, we need to stop here and say, okay, what are we being asked? Find the temperature. Now we know that S, which is playing the role in my problem, is my y, right? That stands for salmon. So the y right here, the 6,592, that's the number of salmon. And then again, if I remember that x is the water temperature in degrees Celsius, I would say, oh, well, when it says find temperature, it's asking me what is x at the maximum. So x is equal to approximately 12 degrees Celsius. So for number 2, 12 degrees Celsius, because again, it wanted that temperature. Here's number 3 on your review sheet. We're given a table of data, years and violent crime rates between the years 1995 and 1955 and 1995. We're being asked to use our calculator technology to find a cubic function, that's important, that's the best fit for this data. So basically, this exercise here is a technology exercise. It's not something that's supposed to be very difficult. It's just plugging numbers into your calculator and generating an equation. The very end of the problem, of course, says, according to the model, so please use what you just found with your calculator to predict the violent crime rate in 2002. So let's begin with remembering what to do with our list values. Now the word problem tells us, let's see, where does it say it? Where x is the number of years after 1955. So what I've done right here on the left is actually beside the years I've written out x's that correspond with 1955 being year 0, counting up until year 1995 where that's 40. As we go into our calculator, I'm going to put that into L1. So I'm going to hit Stat. Let's turn the thing on first. Edit. And then in L1, notice I've already put the x values in there, the years. Then in L2, I put my y values in by typing and hitting enter all the way down. Remember, guys, if you have data in one of your lists that you need to clear out, you can do this by going up to the very top header, hitting clear and then enter, and then entering your data, because otherwise you'll get an error with whatever it is that you generate. The calculator is literally going to use every value in these lists. So you don't want extra values, even if they're zeros, in those lists, because it will mess up the calculator. Now that I've got this in there, this data, I'm going to hit Stat, going over to Calc, and let's see, they told us to do a cubic function. So I'm going to choose number 6, which says cubic regression. Whenever I generate any function, and I encourage you all to do this as well, I send the information to my calculator's brain, also known as Y1 in the Y section. So I'm going to say variables by hitting the vars button, going across to Y vars, enter, enter. So now I've said, please make me a cubic function. Please send the information not only to the main screen, but also to the brain of my calculator, where it will graph it as well. When I hit enter, I get enough information on the main screen to actually write this function out if I wanted to. Noticing that all I need to do is substitute values in for A, B, C, and D, and then I would have a function counting down from the third power down to no power of x. So that's pretty easy as far as if you were just writing the model. Now, we're expected to take an extra step, but it's not a very complicated one. What it's asking us to do, the very last part of this, is it says, according to the model, please predict what the violent crime rate is in year 2002. In order to do that, we need to remember that we adjusted our years, starting with 1995. In other words, if we're looking at year 2002, which is an X value, that's also important to note, we need to subtract 2002 minus 1955. We will get 47, which again, it's very important to know which letter this is, if this is an X or a Y value. It's an X, so in my calculator, I'm going to put in X equals 47 in some way. There's actually a few different ways. You can go look at your table, you can look at your graph, and I'll also show you a trick in just a second on how to actually use functional notation literally in your calculator. Also remember, if you're someone who likes to do algebra by hand, you could have written the function out and plugged in values for X being 47 everywhere you had the X. The reason I'm choosing to use the calculator here is because it does cut down a little bit on the rounding error. So, for example, I'm going to start first with my graph. So, let's see, I'm going to start on a zoom that's standard to see what I've got. Actually, I bet the best choice will be to start by zooming to my stat. So let's do that. I'm going to say zoom stat, which is number 9 under your zoom button. There we go. Now I can see some data that looks more reasonable. Window button, I can go in here and I see X min of -4, X max of 44. So I already know that if I'm using the picture to get this, let's go back to the graph, and I'm interested in the X value of 47, I'm going to need to hit zoom out, because the calculator will give me an error otherwise. If it's not showing up on the picture, the calculator will not generate the data for me. Now that I've got a larger picture, let's try second calc value. I'll put in a value of 47 for my X, hit enter, and I'm getting Y equals 9.989 approximately. So that's the first option that we have when using technology. Option number 2 is to use functional notation. So I'm going to go back to the main screen. Remembering, of course, guys, that in Y1 you actually have your function stored in the brain of your calculator. And the calculator remembers that Y1 is only this function right here. So again, the main screen, I can call that up. I can say, by hitting the vars button, and then Y vars, I can say Y1, like normal. I can use parentheses like I normally would when writing something like f of x, f of 2 or something like that, y1 of, and the x value here is 47. Close the parentheses, hit enter, and check that out. It actually generated the answer for me without having to play with a picture or anything. So again, I get the same answer. Also remember, guys, that you know how to use the table. So if I hit second table, let's see, I'm looking for 47. So I have to scroll down a lot, or I could just start at 47. Let's see, I bet I can get there pretty quick though. Oh, I gotta change my, instead if I hit the plus, I can do change table within the table. So I'm going to change that to change size of 1. So when I look at 47 in my calculator, let's scroll down more, on the table, I can also get the same answer. Let's keep going. 47, when I go across to the matching Y1 value, again, I'm getting the same answer. So there's several ways to use technology to get the most accurate answer. And again, you could also do this by hand. There may be some rounding error. Just use some care when you're choosing which answer down here. On some of these problems, especially this review sheet, I've noticed that the problem we're about to do, number 4, doesn't exactly match. So you're going to have to use kind of some reasoning skills and understand that the reason we're having this error is because there's rounding error in the problem. So the best thing to do if you're nervous on the test is to just write down the answer you've gotten and then circle the one that you think is closest, so that I can give you credit even if you didn't choose the best one.